Antimatter touches matter. Both cease to exist. Pure energy. Nothing left. Not ash, not debris, nothing. The most complete destruction physically possible in this universe. That part you might have heard. But here's what you probably haven't heard. Antimatter wasn't discovered in a laboratory. It was discovered in an equation. My equation. In 1928. 4 years before anyone saw it in nature. And the real story of antimatter isn't about explosions. It's about a question that sits underneath all of physics, underneath all of existence. Why is there anything at all? Because, according to the best physics we have, there shouldn't be. Let me show you what I mean. In 1928, I was trying to do something specific. Quantum mechanics worked, special relativity worked, but they didn't work together, not cleanly. The Schrödinger equation described quantum behavior, but wasn't relativistic. It broke down at high speeds. I needed an equation that satisfied both simultaneously. What I wrote down described the electron perfectly. The right mass, the right charge, the right behavior, the equation worked. But it had two solutions. The first solution was the electron. The second solution described something with exactly the same mass, but opposite charge. A mirror electron. A particle that had never been observed, that nobody had predicted, that had no place in any model of physics at the time. My first instinct was that the second solution was mathematical noise, an artifact, something to be explained away. But you can't dismiss solutions to correct equations. If the equation is right, and it was right about the electron in every detail, then the second solution is telling you something real. In 1932, Carl Anderson was studying cosmic ray tracks in a cloud chamber. He saw a track that curved the wrong way in a magnetic field. Same curvature as an electron, same mass, but opposite charge. The positron, the first antiparticle. Mathematics had predicted it 3 years before anyone saw it. That moment, an equation insisting something exists before any instrument has found it, and then reality confirming it, is one of the most extraordinary things that has ever happened in the history of human knowledge. The universe runs on mathematics deeper than our intuition, and sometimes the mathematics shows us what's there before we can look. So what is antimatter exactly? Not a parallel universe, not dark matter, not science fiction. For every particle of matter, there exists a corresponding antiparticle. Same mass, opposite quantum numbers, opposite charge, opposite everything that can be flipped. The electron's antiparticle is the positron. Same mass, positive charge. The proton's antiparticle is the antiproton. Same mass, negative charge. Every particle we know has an antimatter counterpart. And when matter meets antimatter, they annihilate completely. Not like a chemical explosion where atoms rearrange and release some energy from broken bonds. Not like fission where a nucleus splits and a fraction of its mass becomes energy. When matter and antimatter meet, the entire mass of both particles converts to energy. 100%. Nothing remains. No particles, no fragments. Pure electromagnetic radiation, gamma rays, traveling outward at the speed of light. This is E equals mc squared applied completely, without remainder. Here's the number that makes it concrete. 1 gram of antimatter annihilating with 1 gram of matter, 2 grams total, about the weight of a paperclip, releases approximately 180 terajoules of energy. The nuclear bombs dropped on Hiroshima and Nagasaki combined released roughly that amount. From 2 grams, not from tons of enriched uranium, not from a complex weapon system. 2 grams of matter and antimatter in contact with each other. That's the most energy-dense reaction physically possible in this universe. Not approximately, not in practical terms, fundamentally, there is no reaction that releases more energy per unit mass. Matter-antimatter annihilation is the absolute ceiling. Now, here's where the explosion becomes the least interesting part. Think about the Big Bang, the beginning of the universe. In the first moments, the universe was a hot, dense plasma of pure energy, and energy, when it's energetic enough, converts to particles. Particle creation. Every time energy produces a particle, it produces the corresponding antiparticle. That's not a rule we imposed, it's what the physics requires. Conservation laws demand it. For every electron created, a positron. For every quark, an antiquark. The Big Bang produced matter and antimatter in equal quantities. Equal, which means they should have found each other and annihilated. All of it. Every matter particle meeting its antimatter partner, everything cancelling. The entire mass content of the universe converting to radiation. The universe should be nothing but light, a vast, featureless sea of gamma rays. No atoms, no molecules, no chemistry, no stars, no galaxies, no planets, no life, no you. And yet, here we are. The universe has matter in it, vast quantities of matter, hundreds of billions of galaxies, each with hundreds of billions of stars, each star containing more atoms than your imagination can hold. And almost no antimatter, almost none. Something went wrong with the cancellation. Something, in the first fraction of a second after the Big Bang, treated matter and antimatter differently, broke the symmetry, created a tiny imbalance, approximately one extra matter particle for every billion matter-antimatter pairs. Everything else annihilated, as expected, but that 1 in a billion surplus couldn't find a partner. It survived. That surplus is every atom that exists, every star, every galaxy, every ocean, every living thing. You are made of the 1 in a billion particles that had no antimatter partner to annihilate with. Your existence is the debris of an almost perfect cancellation. Now, what caused that imbalance? That's where physics found a crack in the mirror. Physics has a principle called CP symmetry. The idea that the laws of physics should be identical if you replace every particle with its antiparticle and mirror the spatial coordinates. Charge conjugation, swap matter for antimatter. Parity, flip the mirror. Do both simultaneously and the physics should look the same. For a long time this seemed obviously correct, a fundamental symmetry of nature. In 1964, James Cronin and Val Fitch discovered it isn't. In the decay of certain particles called kaons, matter and antimatter behave slightly differently. Not much. A fraction of a percent difference, but real, measurable, confirmed. The universe doesn't treat matter and antimatter as perfect mirrors of each other. The laws of physics are subtly asymmetric. This is called CP violation, and it's our best clue to why the universe has matter in it. But here's the problem. The amount of CP violation we've measured, in kaons, in B mesons, in everything we've looked at, is real, but it's nowhere near large enough to account for the matter-antimatter asymmetry we observe. The asymmetry in the universe is 1 part in a billion. The CP violation we found in particle physics explains a tiny fraction of that. Something is missing. There's more asymmetry than we've explained. We don't know where it comes from. This is not a philosophical puzzle. It's a concrete, specific, measurable gap between what our best theory predicts and what we observe. The standard model of particle physics, the most tested theory in the history of science, cannot explain why you exist, cannot explain why there's matter rather than nothing. The gap is right there, in the numbers. Some physicists propose that antimatter didn't disappear, it separated, that somewhere in the universe there are regions dominated by antimatter, anti-galaxies made entirely of antiprotons and positrons and anti-atoms separated from matter regions by vast empty voids. If two such regions ever collided, galaxies of matter and antimatter meeting, the annihilation would be visible across the universe. We've looked for signatures of this. We haven't found them. Others propose new physics beyond the standard model, new particles, new symmetry-breaking mechanisms, new sources of CP violation that would produce the right asymmetry. Experiments at CERN, at the Large Hadron Collider, and at dedicated antimatter experiments like ALPHA and BASE are searching for tiny differences between matter and antimatter that our current theory doesn't predict. So far, antimatter behaves almost exactly like matter, just with opposite charge. Frustratingly, precisely symmetrically similar. Every measurement comes back confirming the symmetry we know is broken, but not showing us where the extra breaking is. The antimatter mystery is one of the most important open problems in all of physics, not because of the explosions, because the answer tells us why anything exists. Now a practical note, because this comes up. CERN makes antimatter. Real antiprotons, real positrons, measured and stored. The technology exists, the physics is confirmed. You can make antimatter in a particle accelerator. The cost, roughly $62 trillion per gram. That's not a typo. Not because the raw materials are rare, the energy to make it comes from electricity, but because the process is phenomenally inefficient, and because storing it is almost impossibly difficult. Antimatter can't touch anything. The moment an antiproton contacts ordinary matter, a wall, a molecule of air, anything, annihilation. So it has to be stored in magnetic fields, suspended in perfect vacuum, never making physical contact with any material. The largest amounts ever stored at CERN are measured in nanograms. The idea of an antimatter power plant, the science fiction spacecraft engine, requires solving storage problems that are currently separated from our best technology by many orders of magnitude. The physics is real. The energy density is real. The engineering gap between here and there is almost unimaginable. But here's what I want to end with. Not the explosions, not the energy density, not the engineering. The question underneath all of it. You exist, I exist. The stars exist. The galaxies exist. All of it made of matter. Protons, neutrons, electrons, assembled into atoms and molecules, and dust and rock, and ocean and living things. According to the physics of the early universe, none of it should be here. Equal matter and antimatter should have produced perfect cancellation. Everything should have annihilated. The universe should be a sea of gamma radiation, empty of structure, empty of chemistry, empty of anything that could ask questions. Something broke the symmetry. 1 part in a billion. 1 extra matter particle for every billion pairs. We know this happened. We know CP violation is real. We don't know if we've found enough of it to explain the universe we see. We don't know what mechanism produced the asymmetry. We don't know where the antimatter went. We don't know if there's a region of the universe made of it, waiting somewhere in the dark. But we know this. Your existence is the consequence of a broken symmetry in the first fraction of a second of time, a flaw in the mirror, an imperfection in what should have been perfect cancellation. The universe is slightly asymmetric, and that slight asymmetry is the difference between a universe full of structure and life and a universe of light and nothing. You are here because the universe isn't perfect. The most explosive fact about antimatter isn't the energy it releases when it meets matter. It's that the fact that there's any matter for it to meet, that the meeting is possible at all, is the deepest unsolved mystery in physics. and I find that far more interesting than any explosion.